Hello everyone, welcome to John Mac Classroom. In this video, I'm going to discuss the example for parametric differentiation. So kindly refers to the question, given the x is equals to t over 1 minus t, and we have the y is equals to 1 plus t. Find the dx in terms of t. Hence, determine the value of t such that the first derivative, or we can say the dy dx, is equals to 1. Followed by the b, evaluate the second derivative for the values of t in part A above. So before we start, kindly state the rules for quotient rule differentiation. So here we have d dx for the situation u over v, and we have v u prime minus u v prime over v squared. So focus on the x. So in here, we are going to differentiate the x with respect to t. So kindly name it as u and v. So dx dt is equals to, we have v, which is 1 minus t. Differentiate the u with respect to t. So we will have 1. Minus, again, we have the u, which is the t. Differentiate the v with respect to t, and we will have negative 1 over the v squared. 1 minus t bracket squared. So kindly simplify the situation. So we will have 1 minus t plus with the t over 1 plus t bracket square. So the dx dt is equals to 1 over 1 minus t bracket square. Next, focus on the y 1 plus t. dy dt is equals to 1. Next is to find the dy dx. So here we have the dy dx is equals to dy dt multiply with the dt dx. So here we have 1 multiplied with, do remember to flip the situation because we have dx dt on the left. So refers to the right hand side, we want dt dx. So here we will have 1 minus t bracket squared. So the dy dx is equals to 1 minus t bracket squared. So hence determine the value of t such that the dy dx is equals to 1. So kindly substitute the 1 equals to, expand for the right hand side. So we have 1 minus 2t plus with the t squared. So simplify the situation, and we can see that we have t squared minus 2t plus with the 1 minus 1. So we have t squared minus 2t equals to 0. So t multiplied with t minus 2 equals to 0. So the value of t is equals to 0. The value of t is equals to 2, when the dy dx is equals to 1. Next, kindly focus on the second part, evaluate the second derivative. So kindly state the formula. The second derivative is equals to differentiate the dy dx with respect to t. Then multiply with the dt dx. So that is the formula for the second derivative for parametric differentiation. So focus on the dy dx. If we differentiate the situation with respect to t, so we will have 2 bracket 1 minus t to the power of 1. Do remember, differentiate the internal function, and we will have negative 1. Then multiply the dt dx. So do remember to flip the situation. So we will have 1 minus t squared. Simplify the situation. So we have negative 2 multiplied with 1 minus t to the power of 3. So that is the situation for the second derivative for parametric differentiation. So kindly substitute when t is equals to 0 and t is equals to 2. If the value of t is equals to 0, so the second derivative is equals to negative 2 multiplied with the 1. So the answer will be negative 2. So if the value of t is equals to 2, so meaning that the second derivative is equals to, so in here we have 1 minus 2, which is equals to negative 1. Power 3, and we will still have negative 1. Then multiply with the negative 2, so we will have the value 2. So here we are, and thanks for watching.